these are our derivatives. I want to explain to you what you're finding so it makes sense what we're doing and you're not just kind of plugging things in like a little robot. So I want to make sure I explain what we're finding, but then also like show you how to do it, obviously. Okay, so let's say you come across a graph out in the world and you want to find a line that's tangent to a certain point. So let's say I want to find the line tangent to that point. A tangent line, remember, touches the graph at exactly one spot. So this would be my tangent line. Your tangent line, the slope of that is equal to the derivative. And we have a formula for it, and this formula is probably actually going to look familiar to you from one that we saw all the way back in semester 1 a long, long time ago, because they've put stuff in this format for us before. Do you remember seeing this formula before? The f of a plus h minus f of a? Does that look familiar from I was going to say, we've seen that before. Okay, so let me explain what this is. So this is the slope formula. Welcome. Oh, look, hello. A big crew.
Oh my gosh.
Hi.
We're at the student advisory.
Oh, perfect. Okay. Thank you. So we just started. So you are in a good spot, but I need to see your homework eventually, friends who just wandered in. Okay, so we are talking about the tangent line, which is the same as the derivative. Okay, so here's what I want you to think about that we're doing. So let's say we have any point on this graph, and what we're doing is we're starting off actually thinking about it as 2 points. So 2 points make a line, yes? And so we would call that a secant line. Now, if I start moving these closer and closer together, and closer and closer together, and closer and closer together, the closer that I move them together, do you see that my line that's going to give me the slope is more accurate every single time? So as I keep inching them closer together, they're going to get more accurate for what the slope is. Does that sound like a limit when we were inching in on something? Yeah, that's what that is. So the reason that we're taking the limit is because we are inching in 2 points until they become the same point and we're finding the tangent line of it. Now, take a look at this thing. If I write this on the board, tell me what formula this is from the days of yore. Slope. Okay. If one of my points is a plus h and the other is a, and they are converging in on each other, and I'm subtracting them, those are my y values being subtracted. And if h is the distance between the two of them, and it's getting smaller and smaller and smaller until it's 0, this is the slope formula. So this is the slope formula as 2 points inch their way in, so I can find the slope of anything. So I can find the slope of a straight line like we have for years. But then I can also find the slope of something that has curvature to it, which we haven't done much of. We've talked about like average rates of change, but this is going to go even beyond that. So let me show you what I mean. Here is the first one, and it's hard to read. So this really says f of x equals 2x. Oh, you can't see that. Hold on. Let's go down here. So this really says f of x equals 2x. It just kind of got garbled with how it was written. This is my a value that I'm plugging in for the formula, and then this is my f of a. So remember that y is the same as f of x, or f of a, or f of b, or f of whatever your variable is. So if this is x, then this would be f of x. But in this case, we're going to call it a, and then that would make this f of a. So those are my 2 values. So we're going to plug them into this formula. So we are going to find the limit as h approaches 0 of f of a plus h. All right, I don't know what h is, So when I go to write this in, I'm going to leave my h because I don't know what it is. I know I want to approach 0 with it, but other than that, I can't do anything else. My a value I gave you is 3. So I'm going to plug in 3 in place of a. So 3 and a equal to each other. I can sub in one for the other. Minus f of a. What's my f of a? 6. All over h. Okay, that's step 1. I'm just trying to start plugging some stuff in. All right, so let's think about f of x for a minute. Instead of f of x, which is 2x, I want to plug in now 3 plus h. So the limit as h approaches 0. None of this other stuff is going to change for a minute. The minus 6 and the h I'm going to leave. But this I can actually plug in. I can take my 3 plus h and plug it in place of the x. So if I plug it in, I'm going to get 2 times all of that. So I'm going to have 2 times this 3 plus h business. So again, I'm taking this and plugging it into f of x. So I'm taking the 3 plus h and plugging it in right there. Okay. So remember yesterday I said it's kind of that game of like, can I plug it in now? Can I plug it in now? Can I plug in 0 at this point for h? No. Hi. Did you just come to visit?
Question about Thursday thing. Just in the mailboxes, or do we like kind of sneak into their room and put them there? Or
Sneak into their room and put them in there would be my preference. Thank you. All right. Okay, let's continue messing with this and kind of multiplying it out so we might be able to get to a point where we can plug in 0. So I'm going to distribute my 2. So the limit as h approaches 0, 2 times 3 is 6, plus 2h minus 6 all over h. What happens with my 6's? They cancel because I have a positive and a negative. So basically what I have is 2h over h. So again, think about it. Can I plug it in now? Still no. Bummer. Okay. So what do you notice about this fraction, though? Is there something I can simplify if I just have 2h over h? The h's can cancel. So the limit as h approaches 0 of 2. Now, is there a spot for me to plug in the 0 at this point? No. So the limit is just going to be 2. So if there's no spot to plug it in and you just have a constant number, like 5 or 3 or 7, it's just going to equal that number. So almost like thinking about it as a horizontal line at 2, it's going to be at 2 no matter where you are. Whether you're at 0, it'll be at 2. Whether you're at 12, it'll be at 2, right? No matter where you are along that horizontal line, it'll be at 2. So that's why we just get a standard value there. Okay, but they get harder because life, right? Of course they do. So let's do another one. This one says x squared plus 2x, by the way. Again, it's kind of a little garbled. It kind of got a little like shoved in there. All right, this is my a again, and this is my f of a. Again, we know what we're trying to do is we're trying to go to this point and at that point find what the slope is. So I'm going to plug into that formula because that formula is the same as my slope formula. And again, we're thinking about 2 points edging in until the distance between them is 0. So that's why we have the limit as h approaches 0, because we want the distance between our 2 points to be 0. So your denominator is always going to be h. Okay, so that's kind of a easy given. All right, so we have f of a plus h. So f of a, what's a? Negative 3 plus h is just going to be plus h. We don't have any more information, right? We know it's approaching 0, but that's it. Minus f of a. What's my f of a for this one? 3. So minus 3. So be careful with that part because had it been a negative 3, it'd be minus a negative 3, so it'd be plus. All right, so my first step, we plugged in. Now, we're going to take this business and we're going to plug it in here. Okay? So the limit as h approaches 0. I think I'm going to do this on a little Post-it note because otherwise I might run out of space. So here's what I'm going to do. I'm going to think about x squared plus 2x for a minute. And do you see how I want to plug in this? I'm just going to calculate what that is and then go back to my paper in a second. Because do you see how that's going to be kind of a lot of work to actually plug in? So watch what happens. If I plug this in, it's going to be negative 3 plus h squared plus 2 times negative 3 plus h. So do you see how I'm plugging that in place of x, and it's going to be a lot of work. Does anybody else want a Post-it note to do it on separate? Yes. Tell me, I'll come to you. I'm like a big guy. Anybody else want one? I just feel like it's nicer because otherwise we're going to take up a lot of paper. If you change your mind, come grab one. Okay. So this is really negative 3 plus h times negative 3 plus h. This is negative 6 plus 2h. So far, so good? Okay, let's keep going. Negative 3 times negative 3 is what? I'm foiling. Negative 3 times negative 3. 9. Here's a negative 3h. Here's another negative 3h. So what do I have total? Negative 6h's. H times h. H squared. Minus the 6 plus the 2h. Okay. So this whole line of stuff is going to get subbed back in. Before we do, let's find our like terms and combine them. H squared doesn't have a buddy. Bummer. Okay. Negative 6h, what's its buddy? 2h. So I have negative 4h. And then 9 minus 6 gives me positive 3. Okay. So when I plugged everything in to my f of x, it spat out this. So I'm going to go ahead and write just that. I got h squared minus 4h plus 3. Then, do you remember this minus 3 that was hanging out at the end? Put that there. And then remember it was all over h. Okay, so this is this. This is this. And this bit is me taking this and plugging it in here. Are we okay so far? It's a lot of algebra. Kind of like the culmination of a lot of math coming all together here. What happens to your 3's? They cancel. All right. The limit as h approaches 0. Do you see how you still can't plug in 0 for h? We can't do our direct substitution business yet. Look at your numerator for a second. Can I factor that? How? Take out an h. So do you see how we're kind of using those strategies from yesterday? Remember, one of our strategies was to factor. So we are trying to factor and see if that's going to help us. My h's cancel. The limit as h approaches 0 of h minus 4. Okay, so again, have one of those moments. How about now? How about now? Can I plug it in? I can. And so it tells me the slope at that point is negative 4. So if I were to graph this graph and go to this point on the graph and find the tangent line, the line that touches it once, the slope is going to be negative 4. So I'm going to leave this here with this problem. That was me doing some bonus work, so I didn't have to take up quite as much space. Okay, we're going to do another one. Flip to the next. We're actually going to do 2 more today. We're not going to graph, but we are going to still do the problems. All right. Let's remember our formula. I'm going to rewrite it at the top. We are the limit as h approaches 0 of f of a plus h minus f of a all over h, which again is the, oh, you can't see that, hold on, which again is the slope formula in disguise, incognito. We're not going to do this first one because that one's going to get super crazy when you start to plug everything in. Do you see how it's cubed? So that would be 3 sets of parentheses. That's a bit much. All right, the next two are a bit much as well, but in a different way. So we're going to do both of these. We're not going to do this one. This one would have been similar to the one we just did in the strategy behind it. It just, when you would have multiplied it out because it's cubed, you would have had way more work to do. All right, so we are going to do this one. And let's see, I'm going to give you a point. So your ordered pair is 1/2, comma, 8. So there wasn't an ordered pair given, so it is going to be 1/2, comma, 8. So this is my A, and this is my f of A. All right, I'm going to use some of my space up here because you know I always tend to go over. So I'm going to start up here so I've got a little bit of bonus room. All right, the limit as h approaches 0 of f of A plus h. What's my A? 1/2. Plus h minus f of A. What's my f of A? 8 all over h. Okay. So now we need to plug in the 1/2, the 1/2 plus h into the equation. So let's plug that in. So when I go to plug it in, I've got the limit as h approaches 0. Here's my minus 8. Here's my h. So again, those I'm not going to mess with. It's this piece that needs to then get shoved into the denominator there. So I have 4 over, and I'm going to take, where'd it go? I'm going to take this whole bit, and I'm going to plug it into the denominator. So I'm going to plug in 1/2 plus h. Okay, so I'm here. So now I'm looking at it. Can I plug in the 0 now? No. All right, so then typically in these situations, the next thing I'm going to do is try to combine these values together. Do you see how I have 2 separate fractions up here? So I'm going to think of this as 8/1, and I'm going to try to consolidate it into one fraction. So if I have to have this crazy big bonus fraction, I'd rather have one whole fraction in the top. So let's get a common denominator so we can condense this into one thing. I just want one thing up there. It's going to be a fraction, which sucks, but I want one thing, okay? What should I multiply this by so it has a common denominator? 1/2 plus h. And that's coming in as a package deal. If I multiply it to the bottom, what do I also have to do? Multiply it to the top. All right. Here we go. The limit as h approaches 0 of 4. I'm going to make just one fraction this time. So when I distribute, what's this going to give me? The -8 times the 1/2. -4. And then -8 times h, -8h. All over 1/2 plus h. So all I'm doing in this moment, and if you don't like the 1/2, you could even change it to 0.5 if that makes you feel better. All I did is I took this top part and consolidated it into one fraction. So 4 minus 4, and then 8h. And then this is my bottom. And then what do I still need to put that all over? H. There's still an h hanging out down in the very bottom. Can I plug in the 0 now? Shucks. Okay. What happens in my numerator? The 4's cancel out, so that's kind of nice. And now I'm going to think about my keep change flip. So I really have -8h over 1/2 plus h. And then if I think about this as being h over 1 in the denominator, I'm going to do keep, I'm going to change this to multiplication, and I'm going to flip this. So it's going to multiply by 1 over h. Have I lost you yet? It's a lot of algebra. No? So again, this is my keep. That line right there is division, so I changed it to multiplication. And then this is my flip. It was h over 1, now it's 1 over h. Okay, here we go. I've got the limit as h approaches 0 of negative 8h all over. I'm going to leave it factored out for a second. H times 1/2 plus h. So I'm taking this and I'm multiplying it to this, but I'm not actually multiplying it in and leaving them separated. What do you notice can happen within that fraction? The h's can cancel, so gone and gone some more. Now can I plug in 0? Okay, so watch what happens when I actually plug in 0. So I lose the limit because I'm actually plugging it in. Negative 8 over 1/2 plus 0 is just 1/2. And what is negative 8 divided by 1/2? Negative 16. So, if you were to graph this equation and go to this point and find the tangent line, its slope is negative 16, which is the same as me asking you for the derivative at that location. All right, you ready for one more? Yay, you guys are so excited. Okay, good stuff. All right, so this is our last one. That's good. All right, and the ordered pair doesn't have a fraction this time, so that's good too, right? Yay! Okay. Good stuff. Oh, that looks more like a Q. That's still an A. Sorry, my A was verging on a Q. All right, so we are going to start by plugging in like we always do. See if I can keep this consolidated down here so I can fit everything in. The limit as h approaches 0 of f of a plus h. So 3 plus h minus f of a all over h. So again, we're just plugging in for starters. I plugged in my a. Here's my f of a, and there's the h. Are we okay with that much? That's step 1. So it's consistent every single time. That's my step 1. Okay. The limit as h approaches 0. So now I'm going to take this and I'm actually going to like shove it in there into the f of x. So f of x was the square root of x plus 1. But now it's going to be 3 plus h plus 1. So what is that really? Yeah, 4 plus h. And actually, I always like my variable first. It kind of bothers me a little when it's not first, so I'm going to flip the order as well. So again, what did I do? I plugged this in here. So it said 3 plus h plus 1. Well, 3 plus 1 is 4. That's where the 4 came from. And then the h and the 4, I just flip-flop places. All right. And then we've got minus 2 all over h. Can I plug in 0? Can I? No. Okay. So what was a strategy from yesterday that we haven't used yet? I love it when you guys realize and you're like, yay. What is it? Rationalize. Oh, fun. Good. Okay. Sorry, I'm trying to keep us upbeat, people. Okay. So I need to multiply by the conjugate. What's the conjugate of this thing? H plus 4 plus 2. Oh. That's fine. You have your feelings. They are valid about all of it. Yes, it is frustrating. Okay, here we go. Maybe it's almost like tennis. So you know how like in tennis sometimes people like when they go to hit the ball they like do the grunt thing? Like maybe this is like that for us but with derivatives. We've reached the point where we're like maybe that's the noise that goes along with. Maybe that's the noise for rationalizing. I don't know. Okay, here we go. Ready? All right. First of all, okay, sorry, I got us off task. That's my bad. In the bottom, I'm not going to actually do any multiplying because remember, typically something's going to cancel out, so multiplying is not usually the way to go. You could always try it later if nothing works out well, but it usually does. Okay, let's go to the top. If I multiply this by itself, it becomes the square root of h plus 4 squared. So what happens? It's just h plus 4. Okay. This is going to be 2 square root of h plus 4. This is going to be negative 2 root h plus 4. What's going to happen to those? They cancel. So I'm not even going to write them. That's not even worth my time. Now, negative 2 times positive 2 is negative 4. Ooh, do you start, like it's getting better, right? Okay, what happens? What's next? The 4's cancel out. Limit as h approaches 0 of h all over h times the square root of h plus 4 plus 2. Okay. What else can I do? Cancel out the h's. Okay. The limit as h approaches 0 of 1 all over square root h plus 4 plus 2. How about now? Okay, so plug it in. 0 plus 4 is 4. So again, I'm using the limit, so now that piece can drop off. So I have 4, the square root of 4 plus 2. Well, what do we know the square root of 4 is? 2. So I have 1 over 2 plus 2, which is 1/4. Now, this 4, we call it a day. Let's say, this last part isn't bad, I promise. Okay, I know. Okay, so this is my slope, right? What if somebody said, give me the whole equation of the tangent line? I want to show you how to do that. So let's say they said, give the equation of the tangent line. Do you agree I already have the slope?
Yes.
Yes. Okay, so I already have the slope, which is the worst part. Do I have a point on the line? Yes. 3, 2. So I have 3, 2, and I have the slope. So the easiest format to plug this into is your point slope form. So y minus y1 equals m times x minus x1. Does that formula look familiar? Okay, so that is our point slope form. Why do we call it that? Because it's easy to plug in a point and a slope. Like mathematicians are not a creative group of people. We say what we mean. Let's plug in. So this is my x1, this is my y1, this is my m. Y minus 2 equals what? 1/4 times x minus 3. And you can leave it just like this. Now, if you are somebody who doesn't like point slope form and you are just like slope intercept is the best thing in the world to you, could I distribute and then add over the 2 and get into slope intercept? Yes. Am I going to make you? No. So the only thing you could be asked beyond what we've been doing today to find the slope is to take it one step further and find the equation for the line. You're going to use this equation, you're going to use the slope and the point you were given and just plug in. That make sense? Woo! All right, ready for homework? You don't have a lot of problems. Oh, look, there are 4. No. I love that you think 2, but no, but close. Oh, right. How about, I want you to pray. 4 is not that many. When I was a kid, back in the day, back in the 90s, they used to give us 500 problems, and we had to walk to school in the snow with no shoes up a hill. You can do 4 problems. I know, but look at how much time.